Getting some good attendance. Thank you all for joining. And it's about time to get started. So welcome to the Vast and Dremio webinar, Building an AI-Ready Data Stack with Vast and Dremio. We're thrilled to have you here and have you learn about our joint solution together. So I'm Christina Neville. I'm Director of Strategic Alliances and your MC for today. So please do ask questions. Let's keep it conversational. So I'm going to stop sharing so our amazing speakers can introduce themselves. We have two awesome folks on the line. So Colleen, give us a quick hello. Tell us a little about yourself.
Hey, thanks, Christina. I'm Colleen Tarto. I'm Field CTO and Head of Strategy at Vast Data. I've been in the data analytics field for, I don't know, over 20 years at this point. And lately I've been focusing on topics like enabling our customers to do both AI and BI at exabyte scale. So I'm really excited to talk about our partnership with Dremio and the solutions that we've built together.
Awesome. Thanks, Colleen. And for you, Reed?
Hi, everybody. I'm the CMO of Dremio. Really excited also to be with you here today to talk about how we've been solving customer problems such as lowering costs and then moving much faster in terms of delivering analytics and AI projects with Vast. My career has been in the cloud and data analytics space as well, and my background's actually as a data engineer. I've done data engineering and data work before. I made the transition over to business school and jumped onto the marketing side. So it's been really good to sort of see, the consumer and engineering sides come together and what we can actually now take and deliver for customers, which is what we're going to talk to you about today.
Fantastic. Thank you guys both so much for joining. So a little bit of what we're going to cover today. So we're going to talk a lot about challenges and opportunities with data infrastructure, how leading enterprises are eliminating data infrastructure's complexities, and certainly going to talk about AI, because who isn't these days? And then we're going to wrap it up where you can see it live, our new Vast database connector to Dremio. So you'll be able to see it in action. But go ahead.
So one of the things that, Colleen and I run into when we're talking to customers is that we see that, every organization wants to deliver analytics and AI projects faster. And it would be one thing to say, well, this is, you can just sort of take this for granted. But the reality is, if you look at our latest McKinsey report, they're saying that $7.9 trillion of economic value are going to be generated from just generative AI alone. That's taking all of the ML work and all of the other data-driven work that most organizations are doing and ascribing no value to it, and you're still at $7 trillion. And so what has this meant? This has meant you have this race for competitive advantage. I mean, when the numbers are that big, it really relates back to organizations are trying to deliver competitive advantage, sustainable competitive advantage to help drive their businesses. And so they're in a race now. It's either their competitors are going to do it, or new startups are going to do it, or they're going to do it. But what we really find is they all want to do this because they want to go win and make their companies more profitable and more successful and grow, but they're held back. They're held in neutral. And so we see these types of quotes, which is on our next slide, about what customers are running into. And this is what they have slow data access. So they're analysts or engineers and scientists. They can't actually corral the data that's in multiple sources and bring that together and move much faster, because now it's like, okay, I can get that data and get it in one spot. Sometimes it's cost related. It's, hey, they only have so much budget and they can't take on more users running more compute jobs and more into the systems that really are slowing them down. And so these are the types of quotes that we see. Restricted data access slows our pace. Getting data to our analysts fast is vital for decision making. We need to speed up product development. Those are the types of conversations that Colleen and I are in when we're talking to customers, and they're sitting here being like, we need to know how to do this. Sometimes it's like they want to do it for the business. Sometimes it's an executive mandate from the board or the CEO, and it's in their 10K filings. And they're like, we have to go do this. So we want to start off and hear about you. Like, what are your specific challenges? Colleen and I we have some things where we think this is going to end up. But we'll discuss where you end up, and we'll try to tailor items about what we're seeing and some of the best practices you can use as you go and modernize your data platform for the AI generation here.
Yeah, great. And Reed and Colleen, any early Again, we're having people ask, what's your biggest challenge with data infrastructure? Any guesses from your side? You think it's going to come up strong?
I mean, we and I are probably both looking back at the days when we were data engineers. So, it's going to be different from a leadership perspective. But I mean, for me, it was always the same thing. It was always overly complex.
Yeah, I feel like this depends. This will depend. There it is. Complexity starting to come up, number one. I was like, it's going to depend on the role, right? As to where the pain is probably perceived. And so I think what you'll end up finding is on the, if on our architecture and data engineer side, it's going to be around complexity. And on our analyst and sort of data leader side, we're going to look at time to value. And all these other things are really important because you can't do those without like data security and cost, like the cost overruns we already touched on. If the data is not secure, like that's full stop, right? You don't get to go anywhere. And if you can't afford getting more people on the platform and drive adoption, all the rest of these things don't happen. Complexity also slows you down, right? So these things, sometimes these challenges or how they're perceived can be a little bit different.
Mm-hmm. Awesome. Thanks for participation from everyone too in our poll.
Cool. So to that end, one of the things that I have been thinking about a lot lately is that of all of the data we create, most of it is actually unstructured. And it's not something that can be easily put into a database and analyzed because we've mastered that. But the unstructured data is what's interesting today because of all of the work we're thinking about with AI. And generative AI, deep learning, like these are all focused on unstructured data. And that's not something that organizations have built this deep expertise around. So the number I recently heard is that 95% of all data is unstructured, which means that the data infrastructure that we've been building and relying on for analytics and machine learning, that's just focused on 5% of the data out there, the structured data. And we're talking, we're really good at building infrastructure and thinking about gigabytes and terabytes. But if you add in this other 95% of the data, the unstructured data and some of the semi-structured data, now we're talking about petabytes and even exabytes. And that's where vast customers are really thinking. And so it's a whole new ballgame if you want to really activate all of your data, structured and unstructured. And then all of these challenges that we've talked about, just, they're on this entirely new scale. Like cost becomes an even bigger problem. Complexity is an even bigger problem. Time to value is probably going to get longer. And security is a much bigger problem. So we really need to think about how we're going to build that modern data platform with all of these things in mind. So sort of the 6 aspects of this that I think about are that, obviously you need scale, right? Like we're talking about data volumes. And so even if you just have 1 petabyte of data, generative AI is generative. It's generating even more data. And then data obviously is also continuing to grow exponentially. So scalability is going to be key to build something that's future proof. You're also going to need a data platform that can handle structured data like we've been doing all these years, but also be flexible enough to handle semi-structured and unstructured data like video, audio, documents, things like that. You're also going to, speaking to the complexity piece, you're going to want to make sure that your path to value for data is as streamlined as possible. And that obviously is also the time to value. And spoiler alert, this is where things like vast database and Dremio are really going to help you shine. Performance is always a focus. That's that time to value piece again. Because when we're talking about these incredibly large volumes of data, we really need to make sure that our computations are as efficient as possible and our platform is peak performance. And then something that speaks to the heart of Dremio especially is that we need a really user-friendly experience. And we want our business folks to be able to access their data in whatever way that works for them, whether that's Python or SQL or GUIs or anything else. And then finally, where VAST is really going to excel, we want to make sure that we're doing this we're maximizing that ROI by minimizing the total cost of ownership for your data. So making sure that costs don't exponentially escalate with exponentially growing data volumes. And so technologies like Flash are key to that. And so, VAST is going to be a good partner in that. Bree, do you want to tell us more about how Dremio plays with this in the next slide?
Yeah, I mean, we're going to talk about just from the SQL engine perspective of our offering, why, performance and why performance matters so much. And we're talking about scale and cost efficiency and being able to do more. And so I would assume most people that are on the webcast today looking at modernizing data platforms have at least heard or familiar with Apache Iceberg, which we view as the open standard for open table formats. And so as we think about, VAST S3 and a lot of what's getting stored in there and then being able to use and process, we would expect to see, and we do see, that Apache Iceberg is the technology that's chosen very frequently for that. And so when we look at this, we want to make sure that we have a maniacal focus on performance, because that performance turns into price performance. And so this allows you to then transform and process this vast quantity of data that you have. And that's really important in building an AI data stack, because as we'll talk about later, if you don't get the data into the views overall that you need to be able to work on, whether that's something you're using with like the citizen data scientists with auto ML tools like Data Robot and H2O.ai, or if you're going and you're saying, look, I need my hardcore data scientists working on this with their tools, you still have to pull that together. And so we really focus at Dremio on ensuring that we're providing the lowest cost way to do that. And you can see here, like, we end up running on Iceberg 70% faster than Snowflake and over 100% faster than Trino. And so this Dremio engine with VAST, so we'll continue to talk about, really creates this foundation for you to go off and build and innovate in ways that are matter for your organization. All right, next slide.
Thanks, Reed.
Yeah, and I think so I think a lot about the pipeline of data, because time to value, I think, is really the key for everyone. And performance obviously dovetails into that intimately, from, thinking about the actual time for the computations and going back to those basics. It's all about how you're taking data from its source, replicating it, ingesting it into a data platform, curating it, and consuming it. And really, that is the path to value. So VAST is going to focus on these first few steps in the pipeline. We're all about storage, of course, and bringing data into that environment where the data analysis, the BI, and the AI are going to happen. And so basically, VAST is focusing on everything up through, into, and including the curation step.
Absolutely. And then with Dremio, while with Iceberg, we do some ingestion with customers. We see a lot of that work initially then on the transformation side, and then getting it organized in terms of for analytics and AI. And so the customers will take the source data that they're getting largely within the VAST platform here, and then they're going to transform that into, let's say, cubes, aggregations, or just, again, views that they want the data scientists or analysts to be working off of, to be able to deliver value for their customer. And we'll talk about some customer examples a little bit later on.
Awesome. And this really sets the tone where, together our partnership can really, own and optimize the entire, data pipeline. So it's pretty fantastic. So Colleen, tell us a little bit more about, the secret sauce of VAST.
Yeah. So what exactly is VAST? I get asked this question a lot. So VAST is a data platform. It's a software stack built on a new kind of storage infrastructure access, which is called disaggregated shared everything, or DASE, or DAYS. And you might be familiar with shared nothing storage architectures of the past that are based on older hardware, but we built DAYS based on the latest flash hardware. So again, we are software. We have two types of containers, essentially, one that runs the software, and then one runs the NVMe devices, and they're interconnected with this next generation storage protocol, which is NVMe over Fabric. If you're a data and analytics person, you might not know what that is, and that's okay. But basically, this works with the latest and greatest networking, and it's making it so that it's really fast to access and move data around and access your storage. So the machines are able to communicate with remote SSDs like they're directly attached. That's the bottom line. And because it's built with this shared everything architecture, all the compute nodes are completely stateless. We call those C nodes. So when you export data, you're actually doing it in a really, really resilient way. We have these data nodes and these compute nodes that work together to just make this incredibly resilient and fast storage infrastructure because it's shared everything rather than shared nothing. So if one node goes down, not a problem. And all of those CPUs aren't talking to each other. They're all totally independent. And so it's actually linearly scalable, which is really cool. And so because of this, you can actually end up doing both transactional and analytical computations at whatever scale you want. And so it's incredibly efficient. It's built for Flash, which means we get like quality of service and multiple protocols and cost efficiency. But essentially what this means is that it's a consolidated single tier for all of your data, whether it's structured or unstructured or semi-structured. And it's essentially infinitely scalable without the need to like migrate hardware or data from platform to platform as your system is growing and evolving, which is really important if you're moving from a smaller system and then you want to start doing more with AI and more with deep learning, and you need more data and you need to be able to access that data immediately, and you don't want to tier your data. So this DAYS is the backbone of the VAST data platform. Next slide, Christina, please. So all that said, we're taking advantage of basically the latest innovations in storage, and we've built this incredible data platform on top of it that's optimized for Flash and DAYS and all that good stuff. So it's sort of, we think about it in different pieces. So we've got the VAST data store, and that's where all of your data can be accessed with multiple protocols like S3, SMB, NFS, and all of your data is actually cataloged in there as well with the VAST data catalog. And that allows you to really understand at a system level what data you have. The VAST data base is this, we released it last August. It's this revolutionary exabyte scale database, and it's both transactional and analytical. That is, it's going to ingest data in rows, and it's ACID compliant, so you can always trust your transactions. And so it's going to rival most transactional databases in that way. But then as soon as the data is ingested, it's written down into a columnar format. So it's also analytical. And it's going to act like any other data warehouse with performance and scale and features of any other data warehouse. And later this year, we're also releasing the data engine, which is Kafka based, and it focuses on being able to further streamline like data wrangling and ingestion and things like that. And so if you put that all together, we're really able to harness all your data, both structured in the database and unstructured in the data store, with a consolidated platform that scales out as big as you need to exabyte scales, which is really what you need for AI, because AI both has structured and unstructured data. And so, of course, a huge piece of this is our partnerships with things like Dremio that turn it into a true open data lakehouse. So next slide, please. So just to reiterate, the VAST data platform is software that's just going to make all of your data available wherever it lives, on the cloud, on-prem, in IoT devices. And so with the VAST global namespace, you can access all of your data within a single platform and use your favorite lakehouse tools like Dremio. And we have multi-protocol access for all of your unstructured data as well. So next slide, please. And this is just saying the same thing, but essentially like it's one single data platform that can handle operational data processing and BI data curation through tools like Dremio, and also AI training all in the same place. So hopefully now you understand what the VAST data platform is and somewhat how Dremio would fit in as well. So Reed, I'll hand it over to you to talk more about Dremio.
Awesome. So I love how VAST talks about edge, core, and cloud, and so much so that I've also, as the marketing person, co-opted and stolen some of that in terms of how we talk about it as well. And so if you look in the Dremio bucket here, there's three core elements, and the first one here on the left is unified analytics. And one of the things that is great about Dremio is that we have both software and cloud versions. So wherever you run VAST or wherever your data is, you can also set up and run a Dremio warehouse there, Dremio cluster, that's then going to work with your data that's in VAST. And so whether that's on-prem, hybrid, whether that's sitting in a in a manufacturing plant, that takes me back to, again, my days at Honeywell, working on lines there and getting data off of sensors and how that works. It works super well in those types of environments. And these are the types of engagements we have with customers. When we meet our customers on this unified analytics side, And they're basically building a semantic layer out that's infinitely scalable and can be used across the entire organization and then govern into the lake across all the different data sources they're working with. That is what provides them a lot of value initially, where they say, look, I want to create these views and these tables or these cubes across these sources, and I want them to run really fast. That is one of the main initial use cases for Dremio. And as most customers that we work on that are going into a modern data platform with Vast and us, like they still have data in a lot of different places. And we can actually come over the top and help bridge that as the data continues to migrate into Vast. And it provides a seamless migration. So we actually have paths so that, let's say you're on Hadoop or you're on enterprise data warehouses today, there's usually a multi-phase journey that customers go under, and we're able to unify all of that first so you can get to value for your data scientists. We're focused on AI right now in terms of your platform, and for your analysts to be able to move faster right away. And that's what we refer to when we think as a unified semantic layer. Talk about our query engine. What we already touched on the performance and why performance is so important to us and why we continue to get faster is to drive your costs down. So we really are focused on being the lowest TCO query engine for your lakehouse. And that's going to continue to be something that drives us. But also we have this element of federation, like we talked about around unified analytics. If we can't federate to multiple sources, as you're on your journey to Vast, then you can't get value as fast. And so we've added in a set of the most popular connectors to make sure that you can query very quickly. And then last, we have this query acceleration technology. And we have a set of demos around this where what you want your analysts and data scientists to do is to quickly build the views they need in a virtualized manner. So you're not creating copies of the data. Copies make things harder to manage. There's more ETL, there's more costs. And then you also have governance and security issues if you're proliferating data everywhere. But some of those become hot. They might have a lot of usage on them. And so we will then recommend and say, here's where you should build a cube, or here's where you should materialize that view. And our query engine's smart enough that it will recognize these exist and rewrite your query in real time. So at runtime, it will rewrite the query and take advantage of these reflections. So we call that our reflections acceleration technology. And then on the lakehouse management bit, let's say you have all this data going into Vast, you need a way to have a metadata catalog to be able to, provide the operational data the system needs to know where to query it, but also to maintain all the business level metadata around how you're going to manage that. In addition, we then allow them to version their data. And what you'll see when we talk in the AI section is that allows you to take a data version, which is virtualized, not a copy, and align that to a model version of what you're working on, which is key for AI governance overall. And it's also really key to ensure your data is clean, which has an even higher premium in the age of AI. And so you really need to understand how your workflows are going to work. And so when we talk about this and get for data, it's because you can branch your data set, add new data, check it, and then merge it back into the main branch. And you only merge it when you know it's met your quality checks. That is critical. And so we'll talk a little bit more about that later. Colleen.
Yeah, so we've talked about Vast, we've talked about Dremio. Let's talk about how they fit together. So there are really two main ways that they fit together. And the first is the Vast database connector for Dremio. As a reminder, this is both a transactional and analytical database at the scale of a data lake with the performance of a data warehouse. But really, it's very exciting. I actually, just a few weeks ago at Dremio's Subsurface conference, I had the pleasure of announcing the Vast database connector for Dremio. And Jason will actually demo it in just a few moments. But this allows us to really harness the different pieces of the Vast database with this gorgeous UI on top of it for Dremio. And so you're really getting the acceleration from Dremio plus the acceleration from the Vast database, which gives you both transactional and analytical here, which is just incredible. And then you also get all the good, Vast has other functionalities that are really amazing. We've got things like data reduction and data protection and other benefits that you're going to get for free by using the Vast database on the back end. Next slide, please. I'm excited to get to the demo. So the other way that Vast and Dremio work together is actually Vast has an S3 protocol. So you can actually, like I said, store your unstructured and structured data together. But if you had some data that wasn't Iceberg and hadn't yet been ingested into the Vast database, Dremio can obviously, easily talk to Iceberg. And again, you get all those vast benefits like data reduction and data protection. It's scalable out to exabytes. But then also anything in the Vast data stores can be indexed via the Vast data catalog and can then be queried via Dremio, which is very cool. Next slide. And so when you put this all together, really what you have is you have a solution for data in the data store and data in the database. And when it comes out next year, the data engine can talk to both of those. And that's the Vast Kafka-based data engine, just as a reminder. And then on top of that, you can have all of the functionality of Dremio. And so what this really does is it builds a complete data stack, a complete platform for BI, for machine learning, for AI. And it gets you all the way from the storage and compute layer at the very bottom, all the way out to the consumption layer. So going back to that data platform or that data pipeline, that's what we were talking about, is really being able to get from ingestion through replication and store all the storage pieces, and then through curation out to consumption. Next slide.
Awesome. And I think we want to hear a little bit from the folks on the call again. So we're going to announce another poll. Where are you personally with your AI journey?
And so, guys, in some of the next slides, we did do a survey. These are not just Dremio customers; it's a broad market survey as we were building out our 20 and 24 trends and predictions paper, which is free and you guys can access. I'll give you guys a QR code. And so, based on where you are, we'll sort of compare what your peers might look like and give you a sense of what's happening in the space in the next couple. And then we'll talk about specifically how Dremio and Vast work together in terms of the AI ML workflow to help you accelerate what you're working on. All right, a lot of exploration, and then we have 39 that are more project-based. So we have, well, you'll see we have slightly more adoption from our survey that we ran than with the audience we have currently.
I feel like we should have asked the question, whose board has said they need to do AI? And they have no idea what that means. The board has no idea what that means.
Yeah, I mean, it's a mandate in a lot of companies right now. They're just a certain number of use cases or, show me some sort of success coming from this that they're putting budget towards. And so, I think there's a fair ask. It sort of goes back to the McKinsey study again, right? At $7.9 trillion of expected economic impact, boards are like, we have to be able to compete in this space if our business is going to maintain, profitability and growth levels that we have for targets.
Mm-hmm.
Yep. Okay. Well, thanks for that. So number one is, as we're talking about these modern data platforms like data lakehouses that were, with Vast and Dremio, this is the common architecture, we'll say, for AI today. So if you're not in an architecture like this seems to now be, when we did this survey, it was about 4 months ago. No, it's longer than that. It was about 6 months ago. Okay. You can see even 6 months ago that this is the architecture we're talking about in that first section is the predominant architecture for AI today. All right. And this 81%, we think that's going to continue to grow. And so, as Vast is talking about exabyte scale, absolutely. I'm really curious what this will be like next year, and we'll tell you guys too, how much, whether this touches into 90%, but this is the main architecture that's being used in the market. Again, these aren't Dremio customers or Vast customers that we surveyed. This is just 500 overall organizations that we talked to. So the next slide, if you look at where is the market with AI? Now I'm going to tell you, we talked about models in prod. This is not necessary. We did not specify Gen AI models in prod. So this isn't a specific split to say this is how many ML models versus Gen AI models. But overall, if you start adding up the left side of the pie chart, which is 51 plus, 41 to 50, and 31 to 40, right? That section, that's where that 47% number on the left comes from, because that's roughly half. So if you're looking at where's the median, which is what I thought might be the interesting takeaway from the slide, is like, where is that median? The median right now for organizations is about 30 production models. That was, again, roughly 6 months ago. And the QR code has even, all the whole white paper is all the details about where this data, how we got this data, where it comes from, and a lot more description of what that means. But you'll get the sense here of like where your peers are and where's the market going. And they're doing this with lakehouse architectures, with some combination of companies like Vast. So we move to the next slide. So what we see from our customers is a very common path to generating AI, production AI models. And obviously in these last two, model and development, Colin's going to talk more about the specifics. There's a lot of iteration that happens there, but that iteration ends up impacting on the data side, especially around access. So the first thing you have to do is, do I have the data? Do I even know where it is? That's the collection and aggregation. If I don't have it, I got to bring it in. And then I got to know, like, what is it? So if it's in the system and I can't describe it, or there's no wiki, or there's no tags, I can't search it, how am I going to know it's what I need? Well, how does that happen today? I talk to my friend, and I go over and say, hey, where is this stuff? And then they go and they email me, and you get all these emails, and this is how people are Slacks, and they're bringing it all together, and then they're going out and saying, okay, here's how I'm going to go find this. And they write all these scripts and they pull it together. And this is what's had so much draw to feature stores. It's just a part of the work to save time in this whole process of just getting the data together, because we haven't even talked about feature engineering yet. By the time you get to data wrangling, that's just getting the set together. This is something we'll talk about that Dremio is very, very good at, and has accelerated projects for many of our customers by getting the data ready for analytics and AI. We don't do the model building, right? That's something you're going to use a specific library to go do, but you're going to sort of get to that much faster. And so on the model building and model deployment, I'll let Colleen jump in, and also let her jump in on sort of what sizes they see for the data that's being worked on in each of these phases in the life cycle.
Yeah, Christina, before you go to the next slide, yeah, I did want to point out the sizes and the compute that's needed. So, when you're talking about data collection and aggregation, again, both unstructured and structured data is there. And so that's where tools like the Vast Catalog are going to come really handy, because it's going to tell you what's on your system, right? Like, what data do you even have in the first place? And, a lot of our customers have tens of petabytes of data, or even an exabyte. And so, that is a significant amount of data. And so just understanding what's there, you can do on a CPU. But once you start actually processing that data and you still have petabytes of data, you're going to start to need GPUs to start processing it, right? And so that data wrangling and getting into the modeling, you need GPUs. And so you need storage and partners that are going to work with the GPUs. And obviously Vast is NVIDIA SuperPod certified, which is very exciting, but we're one of their premier partners because we are built for that scale. And then once you get into the model building, you've got, again, both unstructured and structured data. And now you're getting down into smaller volumes, though, because that's when you start looking at the hyperparameters and all the different models, and you start thinking about details like checkpointing. And, that's something that you can do on either a CPU or a GPU. And then you get back down to like the results, which are very small, but then you have to go apply the results to the original data set, which again is tens of petabytes. Next slide, please. So like Reed was saying, those last two boxes, the modeling boxes, it's actually very complicated what's going on in those two boxes. And this is, again, sort of a simplification, but you've got that raw data coming in, and then we're finding it somehow. You're doing some data wrangling, as Reed put it, and then you're actually doing that modeling. So you can either start with a pre-trained model, or you could actually build your own model. We do have customers doing that. And if you're building your own LLM, obviously it's incredibly complex, but you probably also have far more data. And so again, you're still working with petabytes of data, GPUs, and then you still have, in those deployment and the inferencing steps, intense data engineering that's happening. And so you need a combination of technologies that can operate at these scales with CPUs and GPUs, but that can also allow people to do that data engineering. So I've been saying this for years, since back when machine learning was all the rage. Data engineering is like 90% of the problem, right? Like 90% of the work you're going to do is data engineering. And then the modeling is 10%, and it's a very interesting 10%. But most of the work you're actually doing is collecting and curating your data. So next slide.
Yeah, so across this workflow, in terms of going from I have this project I want to start to I have a production model in deployment, how do we really help across this line? And so in the first one, with Dremio, we talked about that unified access tier where, as your data is in VAST or other places initially to start as you're on your journey, you can go and see and find all of that. Okay, so it's like you're connecting all of that data together as a starting point. So you're like, okay, cool. It's at least there. It's in this working, we'll say envelope. But then you got to figure out whether, how do you know whether it matters to you? So number one is just having it. Two is it may not be relevant to what you need. And so what we've done around data descriptions and tagging is we've built Gen AI into our product. So as data sets come in, we actually go and tag the data for you, and we'll then say, these are the tags we're applying. This is all through our UI. And you can say, yes, I want those tags, or I want to change those tags. And same thing with a wiki. Like we will auto create a wiki for all the data sets that are being brought into your lakehouse. And then you can say, oh yeah, this is what's going on with that data. So at any point, your scientist or your analyst can come in and they can say, okay, well, I need this type of thing. And they can type that in, or they can use, again, our text to SQL editor and go say, okay, can I find this information? Great. So now that they found the information, now it's about actually wrangling that information together. And one of the things we do really well is around the virtualization of that data. So you can have all the physical sources, you can create the views that you need, and you can work directly on those views. So you can just create the views and say, okay, is this what's going to help me? Because what ends up happening in this process is you're going to create and wrangle the view you want to work with. You're going to work with it. You're going to create some version of that model, and it's not going to be what you want as you go through the iterative process, even just in feature engineering. Okay, so you engineer features, and you say, well, yeah, I see this interaction between these, and I may want to break that apart, or I see these are highly correlated. I want to actually step one of them out. This is what all the types of work that data scientists are doing. Then they can go back and just very quickly, I don't have to talk to anybody, change what the view looks like, and then move forward into the model building process. And the next part is you get in that model building process, because of that iteration, you have to be able to align. You need clean data. We talked about this Git for data versioning, right? So you know that you can quality check it before you merge it and say that's the right source of data. That is a clean source of data. It's a owned source of data. We think of this as data stewardship and data ownership, so that the scientists can trust what they're getting. And then two is they know the version of the data that they built the model to. So you can get version alignment of the data with version alignment of the model. That's required for most AI governance programs that exist out there. Okay, we make that really easy because we actually have those versions. Those versions are stored, and you are really doing this with documentation and Git and so forth, so that you actually have that alignment going on. And then ultimately, you're deploying the model out. And so we just talked a bit about where the data set versioning and reproducibility is really important, because as you're iterating on that model, or your model starts to drift. If you're not familiar with the concept of model drift, it basically just means the environment in which your model was created is now differing from the actual environment in which your model is trying to predict. Okay, so we're just changing those two things, and now you can see that in the data, because you're seeing the versions look different in the data, and it will be able to see, okay, here's what's driving the drift of my model, and then you can improve the model much more quickly. So those are some of the things that we're bringing in, and then VAST is helping with making that whole process really, scalable across the entire group, and then it really fast in terms of all the steps that are required to go and bring that to bear for your projects. So let's go to the next slide. So how does this net out? We're going to talk about some of the customers we have. We actually make the claim we deliver the fastest path to value here. So we have a Fortune 500 retailer who's now able to deliver their projects 10x faster. The way we do this math, so I'll cover them all, then I'll tell you how we do the math. So we have a Fortune 500 customer, this is financial services, who says they'll 7x faster in the delivery of these projects. Again, the project is from, hey, I have the business requirements come to me. It's typically in some sort of ticket or conversation with the business owner to that model's in production, okay? And then you also have a global 2000 software company. This one's specifically in Germany, if you're curious, okay? The way we measure this is they say, here's the timeline it took us to get projects in before we were working in this new model. And then when they go and they say, now we're working in this new model, what is the timeline that they get? And typically this comes to us in the form of, it took us 3 months, or it took us 4 months. Those are roughly what we hear, to it took us, 3 weeks, or it took us 2 weeks, or it took us a week. That's the type of differences that we start to see as customers go across the life cycle and as they mature internally. There's a lot of change management here too that's outside of the technology. As they mature internally, they obviously get faster too in terms of the process. So let's go to the next slide. Demo.
Yeah. If there's one thing I know about me and Reed, it's that we are talkers, but we thought it would be nice to show you our solution. So I've got my buddy Jason Russler here, and he's actually going to do a demonstration of the VAST database connector for Dremio. So take it away, Jason.
All right, thanks, Colleen. Let's do a demo. So what we're going to look at here is a demo of weather data. It's FAA weather data for aviation purposes. We got to look at the workflow up here. It's fairly simple. We're going to demo ingestion of weather data from some FAA sources. It's XML files that they place in the cloud. We're going to ingest them with the Python SDK directly in the VAST database. And then using Dremio as a query engine, we're going to develop some views, some curated data views of the raw data ingested into the database for exposure in Apache superset to populate some dashboards. So to do this, we're going to overview the VAST system, we're going to overview the ingestion system, and then we're going to look at the superset configuration, create the configuration in Dremio, then the views, and then we're going to look at our fancy new dashboards. So to start with, let's look at the VAST database. We can see that we have a table here called metar data. This is the schema of it, or the language, the schema data for the table. And we're going to go over here and see that we have a hierarchy of data sets here. So we drill down into it, we get to our metadata table, or in our metar data. This is with a whole bunch of other data that's housed on this particular system. Going over here, we're going to look really quickly at our ingestion mechanism. So we're looking at, as we get connected here. So we're looking at a Python script that uses our SDK to go out and grab off the internet this parboiled, this zipped up XML file, and it takes it apart, and then puts it into the VAST database using the APIs. This polls every 300 seconds, so it polls every 5 minutes. These stations change usually every half hour to an hour or so. So there's a lot of repeated data in here, but we're just recording each poll. Going over here, we're going to look at our superset dashboard that we're going to populate here shortly. And the way we're going to do this demo is this system is already configured with a database connection to the Dremio cluster, and then the associated data sets here. But none of these are present yet because we have to create them. So let's start by creating the database connection to VAST. We go over here, we click sources, we click add a source, and then conveniently we have this VAST data source placed right here. I'm going to go over here and collect all of these pre-recorded values. Here's our endpoint for the VAST database. We're going to use one endpoint. There's an HA system where you use multiple endpoints, but for the purposes of this demo, we're just going to use the one. And then we're going to put in some API keys. These are the keys needed to talk to the VAST database. These are needed by the Dremio plugin to communicate with it. Like I said, we're going to put in additional endpoints, but we're going to put in that same one and not do a whole bunch of load balancing for this demo. And then we're going to do some configuration. These are tunings for how the workload is parallelized on both the Dremio and VAST. We'll go into the details here, but these are the number of splits and subsplits that that the system is going to use to run the processing. I'm also going to update the metadata update frequency in Dremio to once every minute instead of once every hour. We're going to click save, and look at that. We have 103 databases on the system. And if I drill down into it, it looks exactly like it did on the VAST side here, where we can go to and we can see our metadata. So let's go ahead and run a really quick query here. And we got results, so we know the connection works. So now we're going to create a space. These are just logical spaces within Dremio for data to exist. And we're going to create a couple of views. The purpose of these views is to have data curated from the raw data set in a way that we want to expose. Sometimes these are called data products. But this is just a fancy way of saying a nice curated view. So we have this view, which is intended to dedupe all that data. Remember, I said that we're polling lots of data and there's lots of stuff that's getting polled repeatedly. So we want to go ahead and dedupe that. And then we also want to create some additional fields for calculating density, altitude, and visibility and putting them into the curated data set. And we're going to save that as a view. Okay, beautiful. So we have a new view and we're going to run it to make sure it works. Everything looking good. And now we're going to come back here to the query editor again, and we're going to create another view. This view just finds the very latest poll and exposes it. This way we want current data, usually for the dashboards. This is actually mostly what the dashboards we're going to look at use. And it does the same calculation for density, altitude, and some visibility there. And we're going to create that table. We're going to run it. And we're going to see that we have a working current poll. So if we go here, we can see we have the VAST database connection. We have our two curated data sets that we're looking at. And then if we go back over here, we can see that these data sets correspond. These are the configured data sets. And we should be able to just go to dashboards and load up the dashboard and have it populate. And there we are. This is a bunch of, it's weather data centered around aviation, so we don't need to know what it means, but we talk about flight conditions and whether they're visual flight rules or instruments. And we have some number of stations that are reporting. It's just some basic statistics about the system. 146 million records pulled in the last 7 days, 36 million in the system total. We're using some heat maps for looking at weather data. So in that METAR weather data, there's of course the latitude and longitude and then all the information associated with the weather station. So we can look at things geographically here, temperature, pressure, wind information, and then some nifty statistics like hottest stations reporting. We got one reporting 40 degrees Celsius. We got something here reporting negative 30 degrees Celsius. And we got some nifty density altitudes here, like 17,000 feet. So that looks like it's somewhere in the Indies, I think. But that pretty much completes the demo. We saw a ingestion, and then writing in the data, the weather data to the VAST database. We saw the creation of some data views, curated views in Dremio, and then saw them exposed to Superset to populate these dashboards. Thanks for watching, and it is back to you, Colleen.
Thank you so much, Jason. If you can't tell, Jason's actually an amateur pilot, so that's where he came up with this. And I keep joking with him that metard data with my Boston accent is actually just metadata. Um, so yeah, so this is the flow he did. Hopefully that was interesting to everybody. I always love to see these things in action, but essentially this entire data pipeline, all the way from ingest all the way to curation and then out to consumption, he built that very quickly with Fast and Dremio, which is very cool. Next slide, please. I think we're wrapping up, but yeah, so hopefully the main takeaway here is that Vast plus Dremio here can really bring you that exabyte scale and performance on our all flash data platform, coupled with the like operational efficiency and cost effectiveness. And this is to what Reid was speaking about, just the time to value for data is going to be lower because the complexity is lower. And that's really what Vast and Dremio are giving you together. And then, obviously you're going to be able to do that iterative data engineering that really is key to AI and generative AI that everyone's doing right now. So I think that's it, Christina.
Yeah. And, thanks a million for everyone for joining, hanging on, seeing what we were to show today. This was exciting. We'd love to hear your thoughts. So there's 2 ways to actually, follow up with us further. There's a QR code and you'll get a link to the survey. Or when you exit today's Zoom webinar, the survey will pop up. So please give us feedback, thoughts, follow up. You can always reach out to us. And of course, huge thanks to, Colleen, Reid, and Jason for being a part of today's session. Any and all feedback's always, encouraged. And I also put some links to some pretty nice, documentation we have together, a solution brief, and also kind of more information on our joint solution. So thank you. Any closing remarks, Reid or Colleen? Other than, guys, have a great day. Go for it.
Yeah, no, guys, have a great day. Thank you.
Reid, you're on mute.
There's an open question. I don't know, do you want us to grab that one real quick?
Go for it.
Oh yeah.
Hey, so Jennifer, I'm just gonna go sort of get into this. Jennifer asked about that Lake House mentions around Iceberg, and then talked about the fact that they're really on the Delta Lake format, which if you don't know is another table format, the one that's largely supported by Databricks. And it says, are the integrations the same as Iceberg? That's question one. And then they sort of get into, could Dremio work across, AWS, or they call it the GPU cloud cluster, CoreWeave. Okay. And so the answer for us working across the environments is yes, we can work across those environments. I would even recommend that, with the one that you're using with CoreWeave, you would probably run that in a self-managed environment with Dremio software. And then with AWS, we have a specific managed cloud offering, and you could use that and then bridge across. When you're in the Delta Lake community, everything that we just showed you, like in that demo from a Delta Lake perspective, we can do. So like we can read everything we're talking about from a consumption layer for Dremio is all good. When you're coming to writing data, so let's say you want to actually do the transformation with Dremio from, let's say it's a Delta Lake table into a aggregated Delta Lake table. You're taking a source, let's call it bronze, and you're making that into your silver tier and data models. You will not be able to do that. Okay, so we are not all of the data that Dremio is going to write. So if you're doing those transformations, or you're striving to do those transformations with something like Dremio and DBT and using SQL, you would not be able to do in the Delta Lake world. If your goal is to accelerate, AI and analytics projects by putting us over the top as a consumption layer, that is absolutely something that we support, and we have many customers doing that today that we'd be happy to introduce you to.
Okay. Thank you guys so much for joining, and looking forward to, seeing you guys all in the field. So take care and have a great rest of your day.